Okay, one important thing is to know that expressions and equations are different things, but also presenting work for them looks really different. So to simplify an expression, for instance, here's how the work might look. Just following the order of operations, I had to take care of the exponent first, but notice the given expression I rewrote as the first line of the answer, and you don't have to recopy the expression, but I did here. And then after an equal sign, I wrote something that was equal. For this to truly be equal, I still had to copy things like the plus 8, even though the 8 didn't change. Only 4 squared changed into 16. Even though something didn't change, we still need to account for it in order to really have something that's truly equal. And then after an equal sign, simplify further, equal sign, simplify further, after an equal sign, simplify further. Unlike simplifying an expression, solving an equation, such as 3x plus 2 equals 14, the work looks rather different. So what happens is I've shown this expression work up here line by line, and notice that an equal sign begins each new line of the expression. For an equation, there's this original starting equation, 3x plus 2 equals 14, and then I subtracted 2 on both sides to get 3x equals 12. And notice there's no equal sign to the left of this, okay? It's an equation, and then the next line down is an equation, and then the next line down, after dividing by 3 on both sides, you get the new equation, x equals 4. Notice the equal sign is in the middle. So in this answer, what happened is that each time the next equation, which is one line below, is obtained from the previous by doing the same action to both sides. And each step of simplifying an expression is an expression. So take a look here. You have 60 da 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 plus 8. Okay, that is an expression. And then after an equal sign, what you have here is an expression. And then after an equal sign, what you have next is an expression. So each time an expression turns into an equal expression, which turns into an equal expression. Okay, for an equation, what happens is each line in solving an equation is itself a new equation. So you have an equation, and then your next step of work is an equation, and then your next step of work here is finally an equation. Okay, so I point this out to let's go back and look at the work that was just presented, solve that equation. It's the same work as before. This is correct looking work. This is incorrect looking work. I have seen this very often from people. They will try to write an equal sign to the left of each new line of work when solving an equation, only because that looks a lot like the work here for expressions. So please don't do this. When people do this, they're thinking that equals means the next step. So here, what's wrong with this? Well, the highlighted equal signs down here, I just copied this work and then highlighted the equal signs. I believe that the student is using these equal signs to mean the next step is, and the next step is, right? So I think people are saying 3x plus 2 equals 14, and the next step of my work is 3x equals 12, and then the next step of my work is x equals 4. But that's not what equals means. Equals does not mean the next step is. Equals, the equal sign only means equals. So another version of this that's incorrect I've seen is somebody will write 3x plus 2 equals 14, and then they'll still use an equal sign to mean the next step is, and then they'll write the next equation, 3x equals 12, and then they'll write an equal sign here in this spot to mean, and my next step is, which is that equals doesn't belong, and then they'll write x equals 4. The issue is, take a look, it's somebody writing this or that is saying that all these things are equal. They're saying that 14 is literally equal to 12, but those are different numbers. So it's really overall the same problem. You really cannot use an equal sign to mean the next step is. Equals means equals, and it's true for expressions and it's true for equations. Okay, so what does it mean to solve for x in an equation? That is, what is the significance that links the original equation to the final answer? This idea is important to me. It's to provide a list. Solving is to provides a list of all the numbers and only the numbers which can be substituted for x that makes the original left side equal to the original right side. So as an example, let me pause just to say students often think of what it means to solve for x as in the procedure. Procedure is important, but that's how to solve for x. That's I do things to both sides and I eventually isolate x to be on one side by itself. Yeah, that procedure is important. It's important to talk about how, but it's also important to know when you go through that process, at the end, you have an answer. And what does that answer mean? How does it relate to the original question? And that's what this Q&A here is about. This is a very important idea. I may ask about this or other Q&As that you've seen in the slides during quizzes and exams, but what's important isn't just to memorize that this is an accepted answer to this question, but to really process what this means. So just as an example of trying to illustrate this, we have not talked about how to solve this equation yet, x squared minus 2x plus 1 equals x plus 5. However, even though we haven't talked about how to solve this equation, we can address this Q&A that's going on here and say x equals 4 is a solution to this equation. Here's why. Because if you plug in x equals 4 into all the x's on the left side, this number simplifies right here to 9. And if you plug in x equals 4 to the right side, into x plus 5, we get 4 plus 5, that also simplifies to 9. So they're both 9. X equals negative 1 is a solution to this equation, because if you plug in negative 1 for all the x's on the left side, that'll become a 4. And if you plug in negative 1 for all the x's on the right side, that'll also it'll simplify to a 4 as well. However, x equals 7 is not a solution to this equation, because if you replace all of the x's with 7s on the left side, this, according to the order of operations, simplifies to 36. And on the right side, according to the order of operations, 7 plus 5 will simplify to 12. So the left and right side are not equal by using x equals 7. So x equals 7 does not make the original left side equal the original right side. Okay, let me just step back just to make sure. This set of 3 examples, or rather 2 examples and a non-example, are trying to really address what this question and answer are really talking about, right? So if solving for an equation, we haven't talked about how to solve this. It happens to be a quadratic equation. We haven't talked about how to solve this equation, but the whole point is, even without talking about how to solve this equation, we can at least address, is 4 a solution? Is negative 1 a solution? Is 7 a solution? And the answers to those questions were yes, yes, and no. And that's a really important idea, is even without talking about how to solve, we will later talk about how to solve this equation. But in the end, when you get your final answers as 4 and negative 1, it's important to know the connection back to the original thing. So we just talked about what solving an equation means. Now let's take a moment to talk about how to solve an equation. So this might be a little familiar, and I'll just say, one of the main things you can do in an equation is you can wrap the entire left side in parentheses, wrap the entire right side in parentheses. This step is usually one that is kind of skipped over, but again, it's important to really talk about where the parentheses technically are, even if we don't write them in all the time. Then apply the same action to both sides. It's usually adding the same thing on both sides, or subtracting the same thing from both sides, or multiplying the same thing on both sides, or dividing the same thing on both sides. Remove any parentheses that you can, so don't just remove them, but remove them if they're allowed to be removed. Simplify arithmetic, apply true formulas, do another action to both sides. That's how you end up solving equations. So here's a very, very tiny example to really illustrate all this parentheses business. I know this is a little much, right? I know this is extremely tedious, the approach that I'm taking here, but it is literally what's actually going on behind the scenes. And most of the time you can get away with not writing these parentheses, but there are times that if we don't understand that the parentheses are actually here, it will get us in trouble. So first, wrap the original left side in parentheses, wrap the original right side in parentheses, and then let's subtract 3 on both sides. So x plus 3 in parentheses, still minus 3 in parentheses. On the right side, there was that 8 that was there. So basically, both the left and right side have introduced a minus 3. Then we'll drop all the parentheses we can, which happens to be all of them. And then this 3 minus 3 is arithmetic that we can simplify. 8 minus 3 is also arithmetic we can simplify. And we're left with x equals 5. I know that's a lot of work. I know that students are also usually in the habit of writing like a minus 3 and a minus 3 under this equation and drawing a horizontal line across. I don't necessarily mind that, but those are some, let's call them, I don't know if they would be called cheats or what they should be called, but they will tend to get people in trouble with really understanding what's going on. Okay, some comments about the parentheses. Hang with me here for a second. I know this is a little strange, but the parentheses are technically there in the example we just did, for instance, and we'll see situations later where being this careful is required. For the problem we looked at, you can just get away with x plus 3 equals 8, and then on a new line, x equals 5. That's going to be fine. right? So this workup that you're seeing above skips all the parentheses, but they are technically there, even if we don't write them in. So part of the thing that I think a previous math class might have done is not really talked really so carefully about parentheses, and there's sort of hold your breath and hope that everything works out. We will see lots of situations where things don't work out, and so we needed to talk about the parentheses now. Okay, so you can, by the way, add the same thing to both sides, even if the thing you add isn't seen in the problem. For example, you can take x plus 3 equals 8 and choose to add 4 to both sides to get x plus 7 equals 12. That's allowed. It's mathematically allowed. It doesn't seem helpful in this situation, and so you might say, why should we do that? Well, in a couple weeks, we are going to see situations where a thing gets added to both sides of an equation, and that thing that's added to both sides doesn't even appear in the equation we're looking at. And oddly enough, doing that step in a future type of problem is actually going to be helpful. We won't see this for now, but it's just worth mentioning from this standpoint of when earlier I said you take an equation and you can add the same thing to both sides. I really mean it. You can add the same thing to both sides. That rule applies even if the thing that you're adding to both sides doesn't appear. Okay, doesn't already originally appear in the equation. Okay, one other thing is that each side of an equation is an expression, right? To the left of this equal sign is an expression, to the right is as well. And so you can apply true formulas just to one side or the other, or to both sides individually. So, for example, starting from the equation 3x plus 11 equals 8x plus 16, we can apply the distributive law in reverse, that's in fancy called factoring, to rewrite the right side, and then just leave the left side alone, right? So we'll leave the left side alone. The left side's still just 3x plus 11, just keep it as original. But the right side, if we so choose to, can be rewritten by using the distributive law or by factoring out an 8 and having 8 times quantity x plus 2. Is this helpful or not? It depends on the problem, but I'm just pointing out things that are allowed. It's important right now. I think sometimes people get only tracked into doing something that's useful for this specific problem, but I'm trying to illustrate a much more important point that in principle, this is a thing that we are allowed to do.